Happy Wednesday and Thursday. Hope you're doing well this week. We're going to keep working with ratios. So for those of you who weren't in class, please watch this video, answer the questions in Edpuzzle so you can get a review and earn those points. All right, it is ratio time. We are going to keep working with ratios. We're going to check out how they look in a number of different ways. We've already done some work with these, but I want to keep going and make sure this is something that's really strong and that we really understand. So we're going to start out with this first problem. Tacos cost $2 each. So that means one taco is $2. 2 tacos would be $4. 3 tacos are $6. All right, so we can fill those in because we can just figure them out from the scenario. We're used to stuff like this because we go and buy tacos all the time, if you're like me. But I also want to make sure that we see we can calculate this because right now it's $2. That's pretty straightforward. And we can just multiply by 2, multiply by 2. Or multiply by 3, multiply by 3. When we do that, we're using scale factors. We did some practice with those last week, and we see that we can do that whether we're going horizontally, like we did in this example, or vertically, like we do in the second example, which is the same thing, it's just oriented a different way. We can do times 3 times 3 and get 6. That works. What I want us to see is that we can also move the other direction. We talked about this last week. We can say 1 times what is 2? Oh yeah. Oops, that's not 6. 2 times 2 is 4. Yikes, Mr. Shingle. 3 times 2 is 6. So that 2 that we figured out is our constant of proportionality. Okay. Constant of proportionality. Oh, yikes. And this is way bigger than I want it to be. I want it to be the same orange. And let's do that. Let's do that. Okay. Constant of proportionality. There's a little bit of overlap. So that's going to come up because eventually we're going to have to write an equation. So that works, and we are very comfortable moving in tables. And so what I want to make sure you see is that we can do this same thing with different in different forms, like fractions. So here we see the same scenario. Tacos to dollars. 1 taco is $2. So 2 tacos is $4. 3 tacos is 6. We're just doing the same thing. Times 2, times 2, times 3, times 3. We're using our scale factor again. So these are called equivalent fractions. Because if we try to reduce them back, they'll all go down to 1/2. So one other way that we write out ratios is this third one on the far right, ratios. And that says 1 to 2. We just read it as 1 to 2. So that's tacos to dollars. We see it's written right there. And we can do the same thing. So 2 tacos is $4. 3 tacos to $6. We do the same math calculation. The reason I want to reinforce all the ways these are written is you're going to be given problems on the quizzes that tells you things like, there are 4 students for 8 desks. And it's written like this. 4 students. Okay, I don't know what's going on there. Oh, I see what it is. 4 to 8, and that's students to desks. So if that is written in a weird way for you, you can always rewrite that from here into a table. Students to desks. Or into a fraction if you prefer. I don't think many of us are going to prefer that. But there's a lot of ways for us to rewrite problems so that we are more able to solve them. So let's try to reinforce that with one more example. Now our cupcakes cost $3 each. So it's very similar to the last problem, except instead of tacos, we've got cupcakes. So if one cupcake is $3, two cupcakes will be, $6. Three will be $9. And again, we can do that with scale factors, multiplication, or we can use our constant of proportionality to calculate it. And so these are just other ways of writing 2 to 6, 3 to 9, or 2 to 6, or 3 to 9. We're comparing cupcakes to dollars. Up here we're comparing cupcakes to dollars. So there's a lot of information that we can gather from these different forms. I would recommend taking a screenshot of this right now so you can get it, so that you can use it when you get to the quizzes. Okay? So, you're going to see a lot of those forms. The other part of your task is to go to IXL. So in IXL, you're going to work on K8 and K10. We're going to look at what these same concepts look like as graphs. So, this tells us graph this function, y equals 2x. Doesn't give us any numbers though. So we remember our x's are down below, our y's are along the side here. So what we want to do is we want to just pick a value for x, plug it in, and solve for y. So we'll show our work here. So if I say that x is 1, and I plug it in, y equals 2 times 1. 2 times 1 is 2. So when x is 1, y equals 2. I see where those two lines meet when I put my dot. Okay, what about when x is 2? I plug it in. 2 times 2 is 4. So when x is 2, y is 4. I find where those two lines meet. It's right on that dot. I'm going to do one more. What about when x is 3? 2 times 3, again, y equals 2x, is 6. So when x is 3, y is 6. I put a dot, and then I connect it. Notice that it starts right here. That point is called the origin. And when I connect those lines, those dots, it makes a line. It makes a straight line. Those are the two details of a graph of a proportional relationship. It should make a straight line, go through the origin. If your dots aren't lining up, I would go back and check your work. Okay? So you'll draw that line on the graph and then hit enter and go to the next one. Okay. So those are going to be things you see in K8. When you get over to K10, there's a lot of reading in this. I'll give you some pointers on that once we go through it. So this is good context. Let's read it. Chalk Arcade has Luna's two favorite things, a chocolate shop and an arcade. I'm realizing I'm writing over the words, so I can't do that. Not only that, but Chalk Arcade's loyalty program rewards Luna with free game tokens every time she buys chocolates. The graph shows the proportional relationship between the number of chocolates Luna buys, x, and the number of free game tokens she gets, y. Okay, that's a lot of information. And I see the graph right here. I see a straight line that starts at the origin, so I know it's proportional. Then the question is just, what does the point 5, 10 represent? And it gives me two options. When Luna buys 5 chocolates, she gets 10 free game tokens. Or when Luna buys 10 chocolates, she gets 5 free game tokens. So I would recommend that you look at this point, 5, 10, and look at where it lands on the x value and the y value. So our x value is 5, and that's chocolates. Remember that first one, 5, 10. The 5 is our x value. It always goes x and then y. So if 5 is the x, I can look on my graph and see that it landed on 5 and that the x-axis is chocolates. So x is 5 chocolates. And then I see where the y value landed, and it's at, well, it tells me it's 10, but I can also look over and see that it's 10. So y is 10 tokens. Which answer says 5 chocolates and 10 tokens? The first one. So that's the one I'll click. Okay, here's this screen. I would recommend getting a screenshot of it. On your IXLs, you only have to get to 60 points. So try to get those as far as you can. If you want to go further, please do. When you have questions, please email me, send a message in Neo, and I will be happy to help you.